Our next principle is structured principle. The definition of the structured principle is the static structure of a program should correspond in a simple way to the dynamic structure of the corresponding computations. Simply says the visualization of the execution process. Most of the languages in nowadays created on basis and the principles. So what it should be is understandable. So above principle is used to visualize the execution process. In static scoping enables to see the internal memory partition side of the program code. But in early history languages, most of things dealt on goto statements. There are 3 goto statements: basic goto, computed goto, and assigned goto. Fortran itself, with lot of goto statements, considered as harmful to structured principle. So let's have a look on defense in depth principle. The definition of the defense in depth principle is if an error gets through one line of defense, then it should be caught by the next line of defense. Especially the do loop in Fortran provides several errors due to misuse. But the compiler might not complain for that. Examples of violation: highly optimized do loop in Fortran. By mistake, replace comma with dot and not keep spaces. If Fortran has good type checking system, because it ignores blanks to at least identify the keywords, since it has no good second line of defense. Since Fortran don't have keywords, it allowed to declare anything for name, which are using for identical operations. But for some cases, compilers inform the conflicts, such as misuse, go-to statements. In this case, go-to control statement, which is using in Fortran, is violating defense in depth principle. Now we are going to talk about the impossible error principle. The definition of impossible error principle is making errors impossible to commit is preferable to detecting them after their commission. This principle is violated by go-to statements and pass-by reference in Fortran language. But do loop in Fortran is not violating this principle. We call do loop as higher level because it allows programmer to state what they want, like namely for the commands in the loop to be executed n times. Rather than how to do it. As an example, we can initialize I, then increment it and test it. High-level constructors like do loops are safer to use. Because it doesn't allow programmers to make errors, such as incorrect testing for loop termination. Now we'll move on to the next principle, that is preservation of information principle. The definition of the principle is the language should allow the representation of information that the user might know and that the compiler might need. Go-to statements, which are using in Fortran language, are violating this preservation of information principle. But the do loop was highly optimized and complies with the preservation of information principle.